So for number 15, this original the polynomial has uh, three positive roots representing this height, length, and width. So that means if we make the original function, if we make the factoring, we will have mm, these three positive roots. So if we want to extend each edge by 2 units, that means we want to have the root uh, like this. So to have this root, we can subtract 2 from the equation like this. And now it will have uh, this alpha plus 2 because of this. If we change this x to x minus 2, now for the x value, for the first parenthesis, it will have alpha plus 2. For the second parenthesis, it will have beta plus 2. And for the third parenthesis, it will have gamma plus 2. And then to find the volume of the new box, uh, volume of the new box is determined by the value of a constant divided by leading coefficient. So for this changed equation, the constant value is the minus 2 cubed is minus 8 times 10 is minus 80. And the minus 2 squared is 4. 4 times minus 39 is 156. And for third parenthesis, 29 times minus 2 is uh, actually we should put minus here. So 58. And final one is 6. And it's divided by leading coefficient 10. Uh, yeah, what's the sum of these four numbers? Can you hear me?
Mm-hmm.
Yeah. What's the sum of these four numbers? That's 300. So divided by 10 is, yep. So the new volume is 30.
Sorry, it just took a while for me to type and
Okay.
make it
Yeah.
clear.
Okay. Yeah. So let's see. Where should I go? Uh, yeah. Yeah, let's go to number 16. Yeah, so to be a triangular number, the sum of 1 through the number is the perfect square. Uh, in such case, we are calling the number triangular number. So we want to find the fourth smallest triangular number, and perfect square. Yeah, so to make the sum of 1 through n, the formula is like this. And this value is equal to some perfect square. So this means n and n plus 1 is 2 times n squared. So because n and n plus 1 are the relatively prime, because one is even and the other is odd, so they cannot be, uh, they cannot have the same common factor. So the first case is if n is a perfect square, this n plus 1 should be 2 times another number's perfect square. And the multiplication of this will make this 2 times a large n squared. And because n and n plus 1 are relatively prime, n plus 1 is even number because of this 2. That means n should be odd number. And if n is odd number, u should be also odd number because odd times odd is odd. So we can think of odd number for the candidate of u like this. So when u is 1, when u is 1, n is 1, and when n is 1, v is also 1. So that's the first, the triangular number. It's already given in the problem. So that's why the first triangular number is 1. So that's the first case. How about the case when u is 3? What's the value of n when u is 3?
9.
9. So if n is 9, what will be the value of u, v? V squared is 5, so that's not a perfect square. So 3 is not the case we want. And when u is 5, uh, n is 25. So what's the value of v squared?
13.
Yeah, 13, that's not a perfect square, so that's also not the case we want. And when u is 7, when u is 7, yeah, what's the value of v when u is 7?
3 would be 5.
Yep, so now the v will be also 5, so that's another the triangular number. Uh, am I right? Let me think again. 49,
Yeah, if
50, yeah, so yeah, yeah, 8, 8. So that's the second triangular number. No, 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 no. That's the third triangular number, right? Because n is 49. Yeah. Second, it's a third triangular number. When u is 7, n is 49. And then let's think of the second case. A second case is now n is this 2 times v squared, and n plus 1 is u squared. When once again, because n is an even number, because n 2 is multiplied to v squared. If n is even number, n plus 1 is odd number, so u should be odd number. So we can think of this list of odd numbers. So, but when u is 1, n is 0, it just doesn't make sense. And when u is 3, n is n is 8. Okay, so now what's v? When u is 3, what's the value of v? Because v squared is 4, v is 2, so that's the case we want. So that makes this second triangular number. When u is 3, n is 8. And when u is 5, 24, it's not working. When u is 7, 48, 24 is not working. 80, 40 is not working. 60 is not working. 168 divided by 2 is 84 is not working. 224, 112 is not working. 289. Okay, how about when u is 17, what's the value of v?
12.
Yeah, 12. So now that's working. So 17. Uh, so when u is 17, n is 288. That's the fourth smallest triangular number. So what's the sum of the digit in 288? Yeah,
18.
18. So this is the answer. Yes, for number 17, we need to use some formula for the trigonometry addition. So at first, sine of 2x is equal to 2 sine x cosine x. So mm, we can take out sine x on the left side. And for the right side, this sine of 3x is like x plus 2x. So if we open the parentheses using the addition formula for sine, yep, and then the sine 2x is 2 sine x cosine x. And at this interval, the sin x is greater than 0. So we can divide both sides by sin x because it's not 0. And after this, this cosine 2x is, yeah, 2 cosine squared minus 1. If we use the addition formula for cosine, mm, so we can factor the right side using sum and difference formula. So this means this equation always have one solution. That's this 1 plus 2 cosine x is 0. This means cosine x is minus 1 half. Do you know the value of x when cosine x is minus 1 half? You can use a calculator. Can you find this cosine inverse of minus 1 half? Can you hear me?
120?
Yeah, 120 degrees. So that's 2 pi over 3, right? That's one solution. But we want the case when this equation has more than one solution. That means another solution should come from after the canceling this parenthesis. So if we cancel this parenthesis, a is okay. Yeah, a is 2 cosine x minus 1. So that means, okay, so now cosine x is, and at this range, this 0 to pi, the cosine x value is between plus and minus 1. So that means this a plus 1 over 2 should be between minus 1 and 1 to have the solution. And then, because it should not be redundant, this value should not be equal to this minus 1 over 2. That's two requirements. That means a cannot be minus 2. And when you solve this inequality, okay, so you can combine these two to find this value. So what's the value of p in this inequality? P is minus
Two.
3. Okay. And Q is minus 2. And R is 1. Yeah, so what's the sum of these three?
-4.
Yep. Um, yeah, let's look at number 18. So for T1, from the 1 and 0, we are making the 1 degree counterclockwise rotation and then uh, reflect it across the y-axis. So that means T1's degree will be 1 degree and then like this. I mean, after making this 1 degree rotation and then it's reflected about the y-axis, that means the new degree. Yeah, the new degree will be the 179 degree. And 42. And from this, we make the 2 degree rotation and then reflect again. So that means now the new degree is this one, but because the direction is clockwise, I'm going to use negative 1 degree, 42. And 43, if we rotate 3 degrees counterclockwise, now the new degree is 2 degrees, and then it's reflected across the y-axis. So that means that's 178 degrees. And T4, uh, add 4, and then reflect. That means the new degree will be 1 degree away from the positive x-axis. So the new degree will be minus 2 degree. So when this pattern continues, what will be the number for t when the degree is minus 179 degree? Because we are multiplying 2 here, that's 358. So if we think of the position of this minus 179 degree, uh, uh, it's here because it's it's clockwise rotation 179 degree. And then for T of 359, we are going to add this 359 to 179. Okay, so that makes we are making this rotation. Adding 359 degree means, and then reflect this point across the y-axis. So now it's going back to the original point 1 and 0. So the transformation, first transformation going back to the original is 359. For number 19, so we want to pick up all 13 cards in exactly two passes. So uh, when there are 13 positions for each card, I mean, because there are 13 cards. Yeah, so there are 13 positions. For number one, for number one's position, it can be one of these. One cannot be in the first position. In such case, all the other cards are arranged in according to their number. In such case, just one pass will pick all 13 cards. So that's not the case we want. So that's why the one's position should start from this second position. And then if all the other cards are arranged in order, after picking up one card, and then with the second pass, all 13 cards will be picked up. So that's the case we want. So we can move the position of one from this to this. So that means there are 12 positions for one. And this means uh, uh, 13C1 is 13, but because the first position is not available, we need to subtract 1. That's the case for 1. And let's say 1 and 2s are in order. 1 and 2s are in order means like this. 1 and 2s are in order, and then 3 to 13 now in order. In such case, we are going to pick at first this 1 and 2 according to the order, and after picking them up, the rest will be picked up all together because they are arranged in order. But in this case, one arrangement is not possible. If 1 and 2 starts from their the original position, the other cards are in order. In such case, just one pass will pick up all 13 cards. So there is still one case we don't want. So for the case when 1 and 2s are in order, the second case is like 13C2. So we are picking up the 2 position for 1 and 2. But we should subtract 1 for this first two arrangement. So we can keeping up this arrangement. So if 1, 2, 3s are in order, we first pick 3 positions for these 3 cards, and then for the rest, we will put 4 to 13 according to the order from left to right. But always we need to subtract 1, because if the original has this perfect order, the other will be arranged and just one pass will pick up all cards. So this continues up to 13, like this. So we wanna add these cases all. And to make the sum easier, we are going to use binomial theorem. So binomial theorem means if we make this 13 power, so this is called the binomial theorem. And to find the sum of these 13 c's, when x is 1, the left side is 2 to the 13th power. And for the right side, it's the sum of 13C0 through 13C13. And so if we move 13C0 to the left, now we have the sum of 13C1 through 13C13. So when we add this all together, we want to find the value of 13C1 through 13C13, and we should subtract this 13. 1 times 13 is 13. So if we subtract 13 from both the sides, yeah, so this means this is the value we want, the number of cases. So what is 2 to the 13th power? Something like this. So yeah, can you find this difference? Yeah. So which one is the answer from the choices?
D.
Yep. Yeah, for number 20. There is isosceles trapezoid. So let's make some coordinate for the trapezoid. Because AD is longer than BC. AD is the bottom and BC is at the top. So let's say A's coordinates are A and 0. and these coordinates are B and H. So we can automatically determine the C and D's coordinates. And when there is a point P, let's say P's coordinates are X and Y. So the length of PA is 1. So if we use the distance formula, this is 1. And PB's length is 2. So the square is 4. PC. And 3 squared is 9. 4 squared is 16. So if we subtract the first and fourth equation, 4ax is 15. And if we subtract second and third equation, 4x is 5. And this BC over AD, BC over AD is equal to B over A. So what's the ratio of B to A? Yep. Can you
3 to
simplify?
1.
Yep. One third.
Wait,
One
1 to
third.
3.
Yeah, 1 to 3. So the answer is B. Yep. So number 21. Um, so we are going to use factor theorem. Factor theorem means if one of these is a factor of this P of x, the x value which makes the each expression 0 will also make the P of x 0. That's called the factor theorem. So let's say the expression in A is 0. And in this case, we can multiply x plus 1 to both the sides. It's still 0 because 0 multiplied by something is 0. And if we open the parenthesis on the left side, we have this expression. So this means x cubed is minus 1. Uh, if the expression in A is 0, or x value which make expression in A 0, the x value cubed is equal to minus 1. So if expression in A is a factor of this P of x, when we put minus 1 for x cubed, the polynomial expression will also be 0. That's the uh, principle for factor theorem. So let's test the value of P of x when x3 is equal to minus 1. This means x to the 6th power is 1. So we can divide this exponent by 6 and think of the remainder. So for first one, that 2022 is a factor of 6. Yep. So that means this value will be 1, and for the second one, that's a factor of 3. 1011 is a multiple of 3. So we can use this minus 1. Minus 1's other power is minus 1. And so uh, for the first case, I mean, the value is 1, not equal to 0. So that means the expression in A is not a factor of P of X. So A is eliminated. And in the case of B, we can multiply x minus 1 to both sides. So this means for this to be 0, x cubed should be equal to 1. So that means all values become 1 because 2022 and 1011 are both the multiples of 3. So the value for the polynomial is 3, not 0. So that means B is also not a factor of P of X. And for C to be 0, because x to the fourth power is equal to minus 1, if we make the square, x to the 8th power is equal to 1. So if we divide this 2022 by 8, uh, it's like x to the remainder is 6, and this one is remainder is 3. So I mean, it's not working. It cannot be 0. Yep. Yep. So C is eliminated. In the case of D, so let's say this expression is equal to 0. In such case, we can multiply x plus 1 to both sides, and that means x to the 9th power is equal to like this. Yeah, so this means x to the 9th power is equal to minus 1. Yeah, so let's think of the remainder when exponents are divided by 9. Remainder is 6. But let's say this way. Yeah, to make sure, let's do a square of this. X to the 18th power is equal to 1. So if we divide this by 18, yep, so the remainder is 6. And how about 1011? Okay, that's 3. But the problem is it has this negative sign, but it has positive sign. So uh, it does not make this expression 0 because they are not exactly the same expression. And so the final answer is E. But let's see why expression in E is a factor of this P of X. So we can do the similar thing here. So if this is plus, this is minus. So that means like this. So we don't have to look at 18th power here. So x to the 9th power is 1. So, uh, yep, actually I think the remainder is the same. Mm. Yep, and this expression is the same as this expression because we start as, by saying this one is equal to 0. That means this one is also equal to 0. So that's why expression in E is a factor of P of X.
I'm sorry, could I move? Could I use the restroom before
Oh,
moving
okay.
on
Yeah.
to the
Oh, yeah.
next?
Go ahead. Okay. Yeah. Yeah. Go
Thank
ahead.
you.
Yeah. You're welcome.
Sorry, I'm back
Oh,
now.
yeah. You're yeah. Okay. Good. That's good. Yeah. So I'm solving this equation, this quadratic equation, this one. It says it has two complex solutions. So that means if I make this the uh, squaring, completing the square, it should contain I. That means the set squared should be less than 0 to have the complex number. So that means if there are two, this is Z1, Z2 are the solution of this quadratic equation. Let's say Z1 is plus I, so Z2 is minus I. And then we can find this 1 over Z1 and 1 over Z2. And I'm going to make this the uh, multiplying this conjugate to remove the I in the denominator. Uh, okay, so it's like okay, so 1 over Z1 is like uh, Z2 divided by 10. Mm. Because actually this Z1 times Z2 is 10. So that means 1 over Z2 will be the Z1 over 10. So let's make a quadrilateral using these 4 points in the complex plane. So complex plane means R is the horizontal and this imaginary is vertical. So if Z1 is in the first quadrant, because Z2 has this minus sign, that means it's reflected across x-axis for Z2. And 1 over G2 is G2 divided by 10. So uh, like this. So like this. This is the position for 1 over Z1. And this is for 1 over Z2. So this length is divided by 10. So we can make this quadrilateral trapezoid using these 4 points. And the length of this base, that's just it's the square root of 40 minus c squared plus I minus I. They make this 2 times. And for this one, that's the half, how can I say? The tenth of this base length, like this. And how about the height? This length is c over 2, but because the 1/10 is removed for this height, like this. Okay, so we can use the formula to find the area of this trapezoid. Let's say the area is f of c. So when you add these two bases, times the height, divided by 2 is the area of the trapezoid. So we can simplify expression like this. And then to find the maximum area, we are going to differentiate this function. I'm going to use derivative, the calculus. That means so f prime of c when it's derivatized. I'm going to use a product rule. Product rule means first one is derivatized, and the second one is derivatized. And for the chain rule, the inside is derivatized. And in the case of maximum, this derivative is 0. So that means, but this parenthesis should be 0. So that means this should be 0. So c squared is 20. So c is the square root of 20. So from the choices, which number is close to square root of 20? When you make the square of, yeah, a is close to square root of 20. So the answer is a. Yeah. Yeah, but I think that's enough for today. So, do you have a time on Monday or Tuesday? Which day is good for you?
I'm not going to be available on Monday, but
Okay.
I think I'm going to have to check about Tuesday. I'm
So,
probably going to be available.
so maybe Tuesday. So let's talk about the schedule. I'll ask you maybe tomorrow or the Monday. Yeah.
Hmm.
Yep. So do your
Yeah.
homework. Yep. So see you next week. Yeah.
Bye.
Yeah. Bye. Have a good day.